We're going to go ahead and look at solving systems of inequalities. Last couple sections, we've looked at solving systems of equalities, with meaning equations, but now we'll look at what it is with inequalities. Now, with inequalities, you're going to graph them pretty much the same as we did when we solved systems of equations, except with an inequality, you're going to also have to do some shading. Now, this one here is in the form of y equals mx plus b, so we're going to start at a height of -3, and our slope is 2. So we'll start at a -3 height on our y-axis, go up 2 over 1, up 2 over 1, and so on. And so that gives us this red solid line. It's a solid line because it's greater than or equal to, because that means you're including the line. Now, it's greater than, you're looking for y is greater than, and you can use this idea of shading above or below when you have y on one side by itself. If it's y is greater than, that means you need to be shading above that line. So we're going to shade above, and so that would be this orange area, including this over here. Now, this one is also in the form of y equals mx plus b, so we're going to start at a height of 2, and our slope is -1. So start at a height of 2, down 1 over 1, down 1 over 1, and so on. And so then we get this dotted line. It's dotted because there's no equal to underneath our inequality. Now, y is less than, so that you need to look at the y values that are smaller than that, so that would be everything that's below. So you're going to shade below the blue dotted line. Now, this is an and statement, so you're really only looking at where the two regions overlap. Well, these two regions overlap only where it's purple, so your final answer should just be this here. So for the most part, when you're doing this, I would go ahead and lightly shade above the red. I would lightly shade below the blue, and then erase the parts that you don't need and only leave the part that's overlapped. Or another way you could do it is you could lightly shade what's above the red, and then when you look at the blue, you know you're going to have to shade below, so only shade the part where they both are. And then you don't even have to worry about this because that's not where they both are, and you just have to erase this part up here. So when looking at this one here, we're going to start out by graphing this. Y is on one side by itself, so we're going to start at -3 and have a slope of -2, so that's where we get this red line. Now, y is greater than that, so you're going to end up doing some shading above that line. So we're going to shade up here. Now, I'm going to go ahead and get y by itself here. So we get y is less than or equal to -x plus 1. Then we're going to go ahead and graph that. So we're going to start out at 1, and we're going to have a -1 slope. Down 1 over 1, down 1 over 1, and so on. And it does help to actually go with the correct slope on this. I'm also going to then extend it up this way here. And we know it's only a less than, so I need to have it being dotted, so I'll switch it to dotted. And we're shading below, so that means I only want to shade below. So I'm not going to shade below over here because the red wasn't shaded there, because remember, I'm only looking for where they overlap. So I'm going to just come along and erase the parts that I don't need. So I'm shading below the black, so I'm going to erase what's above the black from the other area. So that lets me know I'm only going to basically be shading in this little sliver in between. And so I would get something like this. Now, if we would choose any point in this yellow highlighted region, it would make both of our two original statements true and correct. So, looking at this one here, we have our slope, we have a +2, our slope is 1/2. So we're going to start out at a height of 2, go up 1 over 2, up 1 over 2. It's going to be dotted and will be shading below according to what this is saying. So when we look at our graph, it's going to be something along this lines here. This one here, it's also a slope of 1/2, but we're going to start out at a height of 4. So we'll start out at a height of 4, go up 1 over 2, up 1 over 2, and since it's above, will be, or greater than, will be shading above, and so we would get this. Now this is an and statement. Once again, we really only want to shade where they overlap. You'll notice these two regions don't overlap, so our answer is technically no solution. So it would really just be an empty graph. Now, we want to go ahead and graph these three inequalities and find the coordinates of the vertices of the corners of the figure that's formed. So I like to go ahead and get y by itself. So I'll subtract a 2x on both sides and then divide by a negative. And remember to switch your inequality sign when you divide by a negative. So here we'll have a line where we're going to start out at a height of 1 on our y-axis because that's our y-intercept, and we have a slope of 2, up 2 over 1, up 2 over 1. It'll be a solid line, and we'll be shading below that because it's less than. Getting y by itself here, we'll subtract x. So we'll start out at a height of 4, and then our slope will be -1, so we'll go down 1 over 1, down 1 over 1. It'll also be a solid line, and since it's less than, we'll be shading below that. This one here, we get y by itself by subtracting our x and then dividing by 4 or multiplying by 1/4, and we get y is greater than -1/4 x plus 1. So we'll start out at a height of 1, and then we'll have a slope of down 1 over 4, down 1 over 4. It's a solid line because of the equal to, and then we'll be shading above that. Now, when we're looking at this, when you graph all three of these on your axes, we're only going to be shading where all three overlap. Well, when you do that, once again, here's our green line, starting at a height of 1, up 2 over 1, up 2 over 1. Our red line at a height of 4, negative slope of 1, so down 1 over 1, down 1 over 1, and so on. Bottom one, start out at a height of 1, and then down 1 over 4, down 1 over 4. And so we just get this triangle. Now, if you graph it accurately on a nice graph or grid, you can actually find your corner point. So you have one corner point here of 3 for your y and 1 for your x, so it's 1 comma 3 in parentheses. This corner point is 0 comma 1. This corner point is 4 comma 0. Now, if you did not graph these accurately or on a nice grid, it would be harder to get the coordinates.